Okay, great. Thanks, Julie. So a bit about myself. I'm a geoscientist. I did an undergrad degree in physics and geology, and then the rocks were a little bit too much for me, so I branched out into geophysics, and that's what I did up to a PhD level till a few years ago. My current role is basically responsible for projects at the Council for Geoscience, all geoscientific projects, from minerals and energy programs, geohazards programs, all manner of things, water, groundwater, mapping, environmental programs. So that's part of my work. A big part of my work is also talking to people who are much more important. These are the people who give us money. And this is politicians largely, but at all levels, right? So people who influence policies, it's not just, guys who are sitting in parliament, but it's, the councillors, people, the chiefs that you meet in the villages, even ordinary people. So those people influence policies in many respects. So my job, or part of my job, and Mahlatsi there makes me do this job, is to talk to these people. It's absolutely important that we get them all on the same level about what we do, as has been mentioned, and it's a very difficult thing to do. A lot of us are not trained on talking to them, but we need to learn, and it's a skill that, even if we sit here for a day, you're really not going to get a full grasp of what is it that you need to do, but the basics would be there, but you need to do it on a regular basis. So that's really a lot about my job. So if you fall asleep, before you fall asleep, here are some key takeaway points, right? So politics and science do mix. We can't get away from it, right? So we really need to start thinking about how these politics influence the way that we do things. And as scientists, we need to change our perspective a bit and step away from really us doing the science and start thinking about why are we doing this science, for what reason. And this is really to say, let us get to a level where we start influencing decisions, policy decisions at a national level. Julie mentioned this. What you are interested in is irrelevant when you're doing this work. It doesn't matter whether you are in geology, geophysics, and you're busy doing fantastic work and you're publishing lots of papers. That is irrelevant. What's relevant is the audience. Okay, so Julie mentioned this quite well. So we need to stop doing science for the sake of science. Okay, so if you're really interested in making a difference, it's all good and well to publish, but it must mean something. Okay. And we've seen recently why this is important, certainly in South Africa, but all over the world. Fracking is an example from the US. A few years ago, when they started, in the US in looking at fracking, it was a big problem, right? And geoscientists were called in to explain why is it that we need to do this. A lot of the discussion that came out, particularly from the US, influenced policy decisions. So geoscientists were called in to testify, say, why is it that we need to do fracking and what policies do we need to put in place? So this is where you can see the relevance of geoscience in policy making. Recently in South Africa, Shell, big oil multinational, was stopped from doing oil exploration offshore. All right, for various reasons, but essentially they didn't consult. Right, so they didn't go into the communities and say this is what we're doing, and that was stopped. Recently, we as in the Council for Geoscience is implementing this carbon capture, utilization, and storage program. So when you go to the politicians and we say to them, we want to take carbon, put it underground, so that we don't pollute the environment. It's a noble thing, right? Now you go to the communities, the farmers, and you say, we want to take carbon and put it underground. So it doesn't matter, right? This story that it's all environmentally friendly and things like that. For them, as a farmer, how is it going to affect my water and my crops? Okay, very, very important to, when we go there, even though it's a noble thing to do, to say, it's all environmentally good, but it starts with them. Okay, so tell them how this will affect them personally. So it's something that we have had. I certainly have had a lot of problems in explaining and decoding it in a language they can understand. And this is the fact that in some cases the media doesn't explain this very well. It's also partly our fault. Now they read this and they consume it, and when you come and say this is good for the environment, they say, to hell with you. All right, so go do it somewhere else, not in my backyard. So this is, I'm sure you've all seen this before, but this is the IEA's pathway essentially to net zero. So what is it that the world needs to do by 2050 to get to net zero? You can pick any block here. Geoscience is front and center to it. Okay, whether you want to reduce CO2 emissions by 4 gigatons by 2035, whether you want to build electric vehicles, whether you're looking at solar panels, geoscience is front and center to this. If you read this report, and I encourage you to do it, okay, so if you read this report and look at who the authors of the report are and the reviewers of the report are, there's very few geoscientists involved in this. But this is a global framework that has been adopted to say we need to go this way, right? So my boss, Mr. Mabuza, mentioned that a lot of these ideas and objectives that we have regarding net zero will never be reached, and he's right, because whether you looking at having electric vehicles, being dominant by 2045, it will never happen unless we find these minerals, and geoscientists must find them. If we had geoscientists doing this, it will probably look extremely different, right? So a lot of countries are taking this and implementing this in their own policies. So already we are starting off from the wrong foot. So let's start with policymakers, okay? So they might be sitting in the African Union, in the European Parliament, but as I mentioned, it's not only these guys. Right? Actually, to me, the most important ones are the lower level guys, the members of parliament, the councillors in the communities that we work, because those are the ones that influence policy eventually. So this is pretty much everybody at all levels of government. Right? These are the holders of policies. So when it comes to us as scientists, we know our information can be useful in terms of guiding policies. We know about the gaps. Julius mentioned a whole bunch of gaps that exist, and we are really not occupying the space where we need to be influencing policy design. And I think it was somebody who mentioned that in universities you don't get taught how to communicate, right? So we get taught to identify minerals, but really not how to communicate to people who are not scientists. In broadly, we need to also get or strengthen how geoscientific organizations communicate the science. In many organizations, you actually don't have somebody dedicated to communicating. So we have a bunch of geologists, geophysicists, geochemists, and all of those. But you don't have a dedicated person who takes this information, decodes it, and sells it to the public. So communicating the value and importance of geoscience knowledge and education. Julie covered a whole bunch of these, so I'm not going to get a lot into them. We use media, we use advisory panels, we publish policy documents and all of that. And in many of these forums, even if you have a bunch of geoscientists forming panels, it is still extremely difficult for them to decode what they want to say. And the best people to decode information to me are actually non-geoscientists. So if you have somebody who's not a geologist, but who's very much interested in geology, and there's a few of them here, sit them down and say, this is actually what we want to say. Now, how do we bring it down to that level, right? There's a lot of reasons why we need to communicate. We've seen in the recent disaster that we've had in Turkey, geoscientists have been called to say what happened, right? Now we get there with our technical jargon. Yeah, you know, the Anatolian plate is moving this way, and people are listening to this. It's like, what is Anatolian plate? You know, so the language that we use is important, and more we are required now to contribute to these current debates, if you like, on fossil fuels. Okay, we all know climate change is happening. That's not a scientific question. Now, some of us are asked, so should we still continue to use coal, right? Now, as a scientist, with all this noise that's happening around climate change and global warming and things like that, it's very difficult to actually get a scientist to stand up and say, I, as a scientist, believe that cutting down coal is a mistake. Right? It's very difficult because it's your reputation on the line, right? First of all, and you're dealing with a whole cult that says cut out all these things and let's go renewables. But there are fundamental socio-economic problems and issues that need to be considered at a policy level that have basically give us the impetus to say we should continue using fossil fuels. Because if we do not, here are the issues that will result out of that. But we're not willing to put our heads on the block like that as geoscientists. So we're not getting out of that shell, and we are still very comfortable in our own little world. So, the future, sustainability, adaptation, all these flowery words that we use in particularly mining in Durban and all these conferences, we are more and more required to say what we think about these sort of issues at a policy level. But there are challenges. I'm not going to go through them. Julie talked a lot about these. The use of jargon. Right. So, when we start, I'll give you an example a bit later about what we mean, and we found it extremely difficult to decode what we wanted to say, and a practical example. Again, being afraid of exposing our position publicly. This is what I've just mentioned now. The institutions that we have, we do not really spend a lot of resources in terms of saying this is how the message that we want to communicate. And there's, a lot of other issues where economic interest trumps scientific advice, and people really, don't listen to us there. We talk amongst ourselves, and that's great. Julie spoke about this. I can talk to you in a scientific language that you understand, relating data and discoveries, but we're not talking about us. It's about the audience, as we mentioned. This is a different way of displaying what Julie was saying, that we're very good at saying, here's a paper, here is the objectives, here's the introduction, here's the methodology, here is the interpretation, and here's the conclusions. Right? That's how we write papers. And we write it to the scientists. Right? So we're not writing it to everybody else. But actually, Julie mentioned, we need to do a 360-degree turn. And I like how some of the journals are expecting authors to now put a plain language summary. So the AGU journals in particular require authors to say, yes, we see all this nice technical abstract, but we want you to write another abstract in plain language. And this is really very good and a very good step in the right direction. So the public and the message you want to get to the public is important, but it's about what the audience wants, not about what you want. So use appropriate language and use analogies. This is very important. So in Eswatini, for example, when we did this geophysical survey, and if you go there, you say, we are doing a time domain electromagnetic survey. It's like, what are you talking about, right? All they see is a big plane, and this thing looks like it's, you're playing juju on us or something like that. Now, how do you decode that? Okay. Mbuiseni there, who's is one of our communication specialists, has a very good way of explaining what geophysics is, and he uses X-rays. Right? Everybody goes to the doctor. When you go to the doctor, they say, we're giving you an X-ray. You've seen an X-ray machine, right? It's exactly what airborne EM is. So once you say airborne EM, you've lost them. But if you say, actually, this method is like X-ray, or it's like taking or heating something in your microwave. Everybody used to have a microwave. It's exactly the same concept. Okay, so you use analogies with politicians, you use analogies with people who are not scientists, then provide context as well. Why are you doing this? Again, I mentioned the carbon capture and storage program. We went there and said, this is good for the environment. Yeah, well, so what? It must be good. What does it mean for me, right? This is very important, emotional connection. I'm not going to get into it because Julie touched it. It's really important that you show your emotional side. And I'll give you an example of this. This happened not last year, 2 years ago, Mapolova in KZN, the diamond rush. So in KwaZulu-Natal 2 years ago, people found diamonds. Okay, thousands of people rushed to this place and started digging the ground. We found diamonds. There's a very funny video on YouTube where this person is calling his brother or his uncle saying, yeah, bend the house. We are going to Dubai. We are rich now, And it was thousands. It was actually a disaster, this thing, right? So people claim to have found diamonds and we were called in. I said, now, what's happening here? Are these real diamonds or what? Now, you can't go there as we knew they were not diamonds. Like, it was basically quartz, right? But we knew this before we even went there because we know that diamonds don't form in this type of environment. But we can't go there and say, you guys are all idiots, this is not diamonds, right? It will look very bad and you won't come out of there alive. Okay, so there had to be a systematic way of doing this, especially with the politicians and with the members of parliament. So you take them all along. The chiefs, members of parliament, the politicians, they say, let's go there and actually listen to you. Okay, let's listen. So we went and they showed us, here it's the diamonds. Oh, this is great. So, no, Mr. Politician, we are scientists, so we're going to take this and test that this is what you say it is. We have machines there that will tell us. And then we'll come back and report to you whether we have found diamonds. Because if we found diamonds, this is great, right? It's a desperate situation. A lot of the people here are very poor and they're expecting instant wealth. Okay, so we had to go do the analysis, even though we knew, do the analysis. A week later, we went back and we said, in a very nice way, respectful way, is that, you are blessed with many things in your land, but not diamonds. Yeah? So, the difficulty was decoding this in a language that they would understand, right? So again, we are not trained to say it in that language. If you were to write a paper on this and you were to translate it to them, you would say, well, Chief, actually, diamonds form in a graphite diamond stability field at 120 kilometers down. They come up and they came up in the Archean with this big lava flow. Nobody's interested in all of that. It's all bullshit to them, right? What we want is to know whether these are diamonds or not, and are we rich or not. Okay? So now we had to go there and say it in a nice way. So then eventually the media got in, and it's like, these things are worthless, and they still didn't believe us. Some of them still didn't believe us. Like, yeah, you want to keep these things for yourself. Well, that's why you're telling us they're not diamonds, right? So it had to be a continuous back and forth with all of them to say, chiefs, please tell your people that this is not what it is, and this is why that is. And, it taught us that example that we need to speak with authority, right? So they needed to trust that we knew what we were talking about, right? So, we had to be credible, and it's absolutely important that you continue to be credible in whatever engagement you do with the politicians. Again, the emotion and empathy. So Julie spoke about empathy, which is quite good. Continuous engagement is key. All right, and we've seen a lot of examples of this, particularly in the US, in some places where geoscientists have actually met. They were invited and they testify in these in these big events with policy makers to make inputs. And when you listen to them talk, you can tell that they've learned to say it in a language that policymakers understand. And it's something that more and more of us needs to learn to do. So how do we do these engagements? There's surveys, there's interviews, there's workshops, there's seminars, policy briefings. We see a lot of these policy briefings. And in the recent reports, the IPCC reports, there's now they have this what they call summary for policymakers. So they have a 150-page report, and then they summarize, they write another report, and that's essentially for policymakers. The language is a little bit decoded. It's a little, it's a lot less intimidating, and it makes a lot more sense. So when you write a report, a technical report, even in your own organizations, try and see how you can put it in a level, write another report essentially, that you can decode it in a language that people can understand. We've recently done this in South Africa, where we've contributed to the development of essentially policy. And in this case, it guides the dissemination of geoscientific data. Okay, so information comes to our organization. What do we do with this information? So we had to contribute to essentially a policy of the state that says this is how this information will be treated. And it was an excellent exercise because it really taught us how to engage with other stakeholders, especially politicians, to develop this so we understand what is their requirements from their side. There are some practical steps, particularly when it comes to engaging policy. In many countries, there are policies that are geared to development of science, right? So we need to learn how science policy is enacted. So essentially learn the laws of your country, right? So how does a paper get to be a policy? Understand how the science is funded, obviously something very, very important, and it's not all possible in many countries, especially in many African countries. Communications, this is why we're here, and your elected officials. A lot of the time we get called in and we say, go talk to the Minister of Home Affairs. They're like, well, why do we have to talk to the Minister of Home Affairs? They deal with like people, immigration and things like that. So you have to know, what are the things that interest them, right? And again, about the audience. Engage in science policy at conferences. This is very important. Publishing policy briefs. This is what I think it's the easiest thing to do, or not the easiest thing, but we need to get into the habit of saying this is our opinion as geoscientists, and people read this, right? And there's a lot of platforms in which you can do this, and it can be on anything. It can be on how we deal with hazards, how we deal with minerals, how we deal with education. So you must get into the habit of publishing these briefs. And of course, the timing is everything, right? So if you're going to write a policy brief, you're not going to want to do it before the elections. They've got other ideas, right? And things that occupy their minds at the time. Make science relevant to practical realities. So this is a paragraph that I'd like to leave you with. So try to craft messages that are not only simple, but memorable, and repeat them often. This is very important. So for us to get into the habit of communication, we have to repeat our messages all the time. Make more effective use of imagery, metaphor, narrative. It's narrative and analogies are important, right? So the example I gave about the geophysics is an example of an analogy. Be a better storyteller, lead with what you know, and let your passion show. So you got to be passionate about this, and I can tell a lot of you are very passionate, so this is a good start, right? So this is where it starts, but you also need to learn to be storytellers, and it's not only in geoscience communication, even if you're in management positions, it's important to be a storyteller. I really would recommend this course. It's called Practical Geoscience Communication. It's a little bit expensive for some of us, But this is version 2.0. It's currently going at $400, but version 3.0 is coming out in the next couple of weeks, and it's $90. So it's really a series of videos that takes you through the basic principles of geoscience communications. So this is what I'm currently going through as a course, and it's run by a guy from, I think this is from Australia or somebody like that. So it's a very good course. If you're interested, I can show you outside the layout because I'm busy going through it, and a couple of references. All right, great. Thank you.
No, thank you very much, David.